Welcome back everyone, this is MikeSytes, and today's video is a critical video for anyone preparing to take the FAA Part 107 Remote Pilot Certification exam. We'll be covering the 10 most common mistakes that will most likely cause a less than 70% failure. The 10 most common mistakes that are completely avoidable if you have the proper preparation. And in order to do that, you'll need to do one thing, and that is to watch this video until the end. Are you ready? Let's go. Okay, mistake number one is misunderstanding airspace classifications. Questions in regard to airspace are almost nearly guaranteed on the Part 107 exam. Class B Bravo, C Charlie, D Delta, E Echo, and G Golf airspace. You will need to know the vertical limits for each one of these classes of airspace, but the most important thing is to determine which one is MSL and which one is measured in AGL. This is where most who are taking the Part 107 exam will make the first mistake. So let's go over this right now. Starting with Class B for Bravo airspace. Class B airspace is where you will find the biggest airports within the United States National Airspace System. Big airports such as LAX, JFK, Atlanta, ATL, and the Class B airspace around these big airports will typically have what's called shelves, and the shelves will resemble an upside down wedding cake. The vertical limits of this Class B airspace will typically extend from the surface of the airport up to 10,000 feet MSL. Notice how I said MSL, mean sea level. Class B airspace will only be measured in MSL regardless of wherever that Class B airspace is. It is not AGL, despite the fact that you're seeing FSC as the abbreviation for surface. The surface level of the airport and the runways on the airport should not be pointing you to AGL simply because you see surface level. Class B airspace is only measured in MSL, and the reason for that is because these big airports in Class B have aircrafts and pilots who are flying with instrument flight rules. They're not flying by using their eyes, they're flying by using their instruments. And any time that you know that an aircraft is flying with instrument flight rules, that means that they have to have a reference point, and these instruments have to be calibrated with a reference point. And the only reference point that these instruments will understand is one that is constant and never changes. And what never changes is mean sea level, the constant level of the ocean. Whereas on land, that level will always change according to terrain, mountains, and regions. Class B airspace is controlled airspace that will always be measured in MSL. Now let's move to Class C, Charlie airspace. Class C airspace surrounds the moderately busy airports. And these airports will fly instrument flight rules, as we mentioned for Class B, but they will also fly VFR, which is visual flight rules. Now, Class C airspace will also look like an upside down wedding cake with two layers. The inner layer, or the one that begins at the surface of the airport, will typically extend from the surface all the way up to 4,000 feet MSL. Now, think about that second layer of that upside down wedding cake. The vertical limits of that second layer will typically have a floor that begins at 1,200 feet MSL and then go up to 4,000 feet MSL. So you see that both layers will stop at 4,000 feet MSL. And notice how I keep saying MSL again, because Class C airspace is only measured in MSL. And I know that some of you will be asking this question. If Class C airspace accommodates IFR for instrument flight rules and also accommodates VFR for visual flight rules, then why is it only measured in MSL? And that is a very simple answer. It's because sectional charts that are issued to pilots and aviators are primarily referenced in MSL, mean sea level. And I know some of you are flipping the pages on your testing supplement trying to find something that is referenced in AGL, and you will. Obstacles or obstructions, for example, are referenced in MSL, but they are also referenced in AGL. And the reason for that is because you are primarily referencing something that is is based at ground level. AGL is a convenience for ground level operations, but if you're flying an airplane and you see a large obstacle in your flight path, you're not going to be worried about what's at ground level. Your only concern is what your altimeter is saying it will be the appropriate altitude for you to fly over that obstacle by referencing mean sea level and also verifying that altitude on your sectional chart in MSL. So in summary, Class C airspace will always be measured in MSL. Now moving to Class D Delta airspace. And the second most common mistake that's made when taking the Part 107 exam is not understanding the correct altitude for the ceiling of Class D airspace. Class D airspace surrounds the small airports, and there will usually be much less traffic than you will see in Class B or Class C airspace. The airspace that surrounds this small airport will not be an upside-down wedding cake. It will be a single, simple, cylindrical shape, sort of like putting an empty soda can around an airport. The vertical limits will begin typically at the surface up to 2,500 feet MSL. Notice I said MSL again. Class D airspace is only measured in MSL mean sea level. It is not measured in AGL. And you notice how you see AGL right next to it on this chart, right? But that's referring to Class E airspace. Now, in regard to the altitude ceiling of a Class D airspace, if you turn to Figure 25 in your testing supplement, you will find many Class D airports displayed on this sectional chart. You should already know that a Class D airspace is depicted by dashed blue lines. And something that you probably don't know, and you've never asked this particular question, is why is it that all Class D airspace will have the altitude limit as a number with a blue box around it? You have to remember that there is a reason for everything that the FAA does, and that number with the blue box around it is a clear identifying factor for pilots to understand that that is Class D airspace. And the mistake that everyone seems to make is assuming that that number inside of that blue box represents the vertical limit or the ceiling of Class D airspace, and that is not entirely correct. If that number has a minus sign in front of it, then the number that you're looking at will not be the vertical limit. It will be a number other than the vertical limit. And notice how I did not say less than the vertical limit. Saying less than 3,000 feet MSL or minus 3,000 feet MSL is not accurate. When you see that minus sign using the words not included, that is the accurate FAA approved phrase. You can go up to it, but don't include that value. For example, Figure 25, Area 4, Fort Worth Alliance, AFW Airfield, Class D airspace. What is the vertical limit or the ceiling of that airspace? Immediately, your eyes should be scanning for a number with a blue box around it. And if you're a sharp pilot, you already noticed that there is a number 30 with a minus sign in it, and there is a blue box around it indicating Class D airspace. And you've been trained well because you know that that minus sign means that you can go up to that altitude, which is 3,000 feet MSL, but you're not allowed to touch it. Up to but not including is the official terminology. And it's just like having a birthday cake and they tell you you can eat everything on that cake except for the icing at the top. And that analogy made it very clear, didn't it? You see, at 3,000 feet MSL with a minus sign in front of it, that means that the ceiling or the vertical limit of that Class D airspace is 2,999 feet MSL. And I just allowed you to avoid another mistake on the Part 107 exam. Now I'm moving to Class E Echo airspace. And this is the airspace that most of you will make your mistakes, and that's because it's a tricky airspace. Class E airspace is controlled airspace that is typically for public use airports. So I know the next question that's coming on my comment section is, what is a public use airport? Well, let me explain. A public use airport is any airport that is open to the general public without prior approval or prior permission or prior authorization needed from the airport owner or operator. And to clear up the myth that you've all heard that these Class E airports are in small, rural, backcountry airports with dirt roads and grass, well, that is not entirely true. A Class E airport can be paved, it can have runways, taxiways, taxiways, lighting, fuel services. It can have instrument approach procedures. The only thing is that they just don't have control towers. And the stereotypical impression is that some people associate non-towered with remote dirt strips with grass and dirt roads. And pilots can approach these non-towered airports or airfields either by using instruments or using visual flight rules. So you see, I'm trying to give you a good understanding about what Class E airspace actually entails. It's controlled airspace, but ATC does not directly monitor the traffic in Class E airspace, such as they would in Class C or Class D. Pilots flying in this airspace will announce their intentions on a CTAF Common Traffic Advisory frequency. And since there's no control tower and ATF is not directly monitoring, and pilots are approaching while maintaining their own separation visually, there's no actual authorization that's needed unless there are certain conditions. But going back to the point that I just made about not requiring authorization, this is the most confusing, misunderstood point in regard to Class E airspace. We're going to discuss this right now, and hopefully this is going to allow you to avoid mistakes. Class E airspace can begin at the surface, it can begin at 700 feet AGL, or it can begin at 1,200 feet AGL. And notice how I'm saying AGL, but unlike all of the other airspace that we've just mentioned, where there is only one reference, Class E airspace can be referenced by both AGL and MSL. And as you can see, Class E airspace is everywhere. It can be from the surface and go all the way up to, but not including, 18,000 feet MSL. Does that sound familiar? If it does, then comment below and tell me what the vertical limit is for Class E airspace. If you're flying a drone in Class E airspace, the question is, do you need authorization? This is an excellent and advanced question, and the simple answer is more than likely no, but sometimes yes. You see, you're only allowed to fly a drone up to 400 feet AGL. Class E airspace will begin at either 700 feet AGL or 1,200 feet AGL. And keep this in mind, Class E airspace can be measured either in AGL or MSL. All of the other classes of airspace, with the exception of Class G, which is uncontrolled, will be all referenced by MSL, mean sea level. And remember this word, either, which begins with the letter E. Class E airspace is either AGL or MSL. And notice that my arrow is still pointing to McClellan Airfield, MCC, Class E airspace, which used to be an old Air Force base, now has been repurposed for general use. The questions here are to circumvent any mistakes on the Part 107 exam. What is the vertical limit of this particular airfield, and do I need authorization to fly in that airspace? It's obvious that both the airport and the runway have Class C airspace directly above it. So this is an interesting and exciting challenge for you to determine the altitude limits of that Class E airspace and whether or not you're able to fly in that area without authorization. So chances are you're not going to be flying in Class E airspace since you have a vertical limit of 400 feet AGL. But if you're operating a drone close to a structure that is 400 feet high, you can fly above that structure for an additional 400 feet, and that would put you at 800 feet AGL. And if the floor of Class E airspace directly below you begins at 700 feet AGL, then you're at 800 feet AGL, meaning you are in Class E airspace. So do you need to get authorization? Here's the thing. If you are within a faded magenta line of Class E airspace at 700 feet AGL and you are operating at 800 feet AGL, you do not need to get authorization. No special FAA waiver or authorization is required when you are within a faded magenta line of Class E airspace. But if you somehow find yourself flying a drone within a dashed magenta line of Class E airspace, then FAA authorization is required required even if you're at the surface of Class E airspace and regardless of altitude. The thing that was confusing everyone, the mistake that everyone was making, is that there is a definite distinction between a faded magenta line Class E airspace and a dashed magenta line Class E airspace. One requires authorization and the other one you can fly without authorization. And this little bit of information that I just gave you is going to help you avoid making mistakes when you're taking the Part 107 exam. And last but not least is Class G airspace, which will usually start from the surface up to 700 feet AGL, and sometimes it will be from the surface up to 1,200 feet AGL. And you can see that there is a direct relationship from where Class G airspace begins and ends and where Class E airspace begins and ends. Class G airspace is uncontrolled airspace. You do not need authorization, and as long as you maintain a vertical limit of 400 feet AGL, then you are flying in compliance with FAA rules and regulations. So now we're on number 5 of the most common mistakes that are made on the Part 107 exam, and that is understanding load factor calculations. So what is load factor? Well, load factor is probably one of the most misunderstood concepts on the Part 107 exam. But to explain this in a way that you will be able to understand it, load factor is the amount of stress, or should I say G-forces, that an aircraft or a drone feels when it's making a turn, a climb, or when it's descending. And contrary to that, if the aircraft is flying straight and level, then it will just experience a normal weight for an aircraft. But when an aircraft is making a banked turn, when it's climbing, or when it's descending, then there is a force that is emitted upon the aircraft, and that force is known as load factor. And by saying force, I'm not referring to an aircraft being a heavy, big military plane or a small little prop plane. Regardless of the size, weight, or velocity of an aircraft, you will be calculating the load factor in the same consistent way. The only thing that will change in regard to the calculation is what number you will use, the value that you'll be using to calculate load factor based on the bank angle of the aircraft. So now that you fully and completely understand that concept, I'm going to explain to you how you can make load factor calculations correctly. First, when an aircraft is flying straight and level, meaning that in any direction there is no degree of angle, it is at 0 degrees in every direction, every point. What I mean is that the wings of the aircraft are completely level and the plane is flying on a perfect horizontal line. That equals 0 degrees for the angle of bank. If you turn to Figure 2 of your Airman Knowledge Testing Supplement, you will see that the angle of bank, when it is at 0 degrees, will correspond to a load factor of 1. And that number 1 is what you're using to make your calculations for the question that they're going to ask you on the Part 107 exam. This is where everyone makes their mistake. You're not using the number that they're giving you for the bank angle to make the calculation. You're using the load factor value to make your calculation. And yes, I know you're still a little confused because there is another component that is missing that I have not explained yet. You see, once you have the load factor value, in this case it's value 1, which means 1 G-force, or 1 equals a normal level flight. A load factor of 1 means everything feels normal. It is equal to what you would experience as normal Earth gravity. So the component that's missing, that's confusing you, is now you have to take how much the aircraft weighs. If the aircraft weighs 30 pounds and you have a load factor of 1, then the calculation is very simple. 30 times 1 equals 30. So that means that the load factor, or the stress that is felt upon an aircraft that is flying straight and level with a load factor of 1 value, means that the 30-pound aircraft will feel like 30 pounds. Did you see how I just broke that down so you understand it? Now let me break it down just a little further. Suppose the aircraft is no longer flying straight and level. It is now making a 45-degree turn. Look to your chart and tell me what is the value that you'll be using for load factor when the aircraft is making a 45-degree angle of bank. You should be way ahead of me and already know that the number that we're going to be using to calculate the load factor, or the stress stress that's felt upon the aircraft is 1.414. And the biggest mistake that everyone makes on the Part 107 exam is that you try to figure out that calculation in your head without having a calculator. Your head is going to tell you that 1.4 times 30 must be close to 30 pounds of stress, maybe 32 pounds, maybe 35 pounds. But when you actually calculate 1.414 times 30, it comes up to 42.42 pounds. And the FAA will try to trick you because they know that the biggest mistake that you made was that you didn't bring a calculator. Now, if you would, go ahead, hit that like button and give me a thumbs up. Now let's talk about another avoidable mistake that you can make on the Part 107 exam, and that is latitude and longitude. So let's do a quick review on the basics. Latitude lines are the flat lines that run horizontally around the Earth. You will see that these flat lines are north and south away from each other. So the flat line that is in the middle of the Earth running around horizontally is called the equator. And from the equator, there will be other lines of latitude that are measured in degrees north and south from the equator. So you can see that all of these latitude lines are north and south from each other measured in degrees. Where the mistake comes and the confusion is that when people say that latitude lines run north and south, then you automatically look at the other lines, which are lines of longitude, seeing that the lines of longitude are running from north to south, and you think that those are latitude lines, but it's not being articulated correctly. The lines of latitude will run around the Earth in a horizontal fashion from east to west, but they are measured north and south from the equator, which is at 0 degrees center line around the Earth. The lines of longitude you will see are the long lines that are running from the North Pole all the way to the South Pole around the Earth. They are running vertically, and you will see these lines that are apart from each other, and those separations by degrees for those lines of longitude are separated from east to west in degrees. So when you see a line of longitude at 90 degrees, then the next one over, or the next line of longitude that you will see, will be just either east or west of it by degrees. Do you see how I'm articulating that so you understand the difference? Something that we were taught in 3rd grade, and even the teachers could not articulate it correctly. The lack of complete understanding invites the opportunity for you to make a mistake on the Part 107 exam. So always remember that lines of latitude are flat, horizontal, and lines of longitude are long, vertical. So enough with the basics. Now let me tell you the common mistake that's made that's going to make you pull every single hair out of your head, just like I did. Go to your testing supplement and turn to figure 26. Look for the degrees of latitude and longitude. And notice how I said latitude first, because whenever it is that you're reading coordinates, latitude degrees will always be the number that you see first. So you should be at the bottom left corner where you see 47 degrees latitude and 99 degrees longitude. Notice how the 47 degrees is under the line of latitude, and there are hash marks or markers that are running from east to west. Am I right? Well, you also have the 99 degrees that's positioned in a way where you can clearly see that it is for a longitude line, and those hash marks or markers are running from north to south. But here is where everyone makes the mistake, and here's where the confusion comes in. Remember how I explained to you earlier that latitude lines are measured from north to south of the equator, and longitude lines are measured from east to west of the prime meridian? If you were not aware of what it is that I just said to you, then you would be measuring the latitude and longitude by degrees incorrectly. You see, the 47 degrees that you're looking at right now is a line of latitude, and on that line of latitude are those hash marks, and you would think that you need to count from east to west on those hash marks in order to establish a correct position, but you are not counting from east to west when you see 47 degrees. You are counting from north to south when you see those lines of latitude because, as I explained earlier, lines of latitude are measured by degrees north and south from the equator, despite the fact that you see that line of latitude running from east to west. And similarly, when you see the line of longitude at 99 degrees, on the longitude line running from north to south, you're not counting those hash marks from north to south. You are counting the hash marks from east to west because lines of longitude are referenced from the prime meridian at 0 degrees east and west of the prime meridian. So in summary, a line of latitude such as 47 degrees, you count the tick marks north and south, and the line of longitude such as 99 degrees, you will count the tick marks east and west. And that is a common mistake that is made on the Part 107 exam. Let's move to the next common mistake, and that is misinterpreting what remote ID actually means. And just so you understand the basics, remote ID is a digital broadcast that is being transmitted by your drone. The information and data in that broadcast contains the serial number of your drone, latitude and longitude position, where the drone is located, altitude, speed, and where the remote pilot or control station is located. And the big mistake that everyone's making is assuming that remote ID only applies to certain drones. But no, remote ID applies to all drones, regardless of category, regardless of weight. Remote ID must be broadcasted by every drone, and the only exception is a drone that weighs less than 250 grams and is being flown recreationally. Now, these days, all drones come with standard remote ID built in, but if you don't have standard remote ID built into your drone, or you simply can't afford to get a remote ID module, there's only one way that you can remain compliant and fly your drone without remote ID, and that is to fly in what's called a FRIA, which is an FAA-recognized designated location where you can fly your drone without needing remote ID. Now, to avoid the common mistake that's always being made on the Part 107 exam in regard to FRIAs is that most people think that a FRIA is only for recreational flyers, and that is not correct. Even a certified remote pilot who passed the Part 107 exam can fly in a FRIA because it's a designated area that allows any remote pilot or any drone operator or anyone flying recreationally to fly a drone in an area where no remote ID is required. And to further emphasize this so that way you can avoid these mistakes, believing that anyone can fly in a FRIA without following the rules and regulations is a big mistake. When you're flying inside of a FRIA, you still need to comply with rules and regulations according to the FAA. You cannot go above 400 feet. You can't fly over 100 miles per hour. You need to keep your drone in visual line of sight at all times. All of these rules apply to you when you're flying within a FRIA. FRIA does not stand for no restrictions for recreational drones only. And the ninth mistake that you'll make is confusing FRIA with a controlled airspace. Now, the mistake that everyone seems to be making is assuming that a FRIA means that it's an area that is uncontrolled, just like Class G airspace. That is not entirely correct. A FRIA may be located in a controlled airspace or an uncontrolled airspace, but the only difference is the fact that when you're flying in a FRIA, you're not required to have remote ID. But if you fly outside of the boundaries of a FRIA, well, guess what? You're going to have to start broadcasting remote ID on that drone immediately. Now let's touch on the last common mistake that's made when you're taking the Part 107 exam, and that is going to be knowing how to read a sectional chart correctly. And all of your ears just perked up, didn't they? Because you know that sectional charts take up a huge percentage of questions that will be asked on the Part 107 exam. I'm going to give you 5 areas that you need to focus on when it's about sectional charts. The first one is confusing MSL versus AGL altitudes. For example, if you open your testing supplement and turn to Figure 25 Area 3, you will see the ceiling of a Class D airspace with a little box with a 30 in it and a minus sign. The mistake that you're going to make is assuming that because you see 30, that means 3,000 feet MSL. Now remember, Class D airspace is always measured in MSL. So is Class C, so is Class B, and they're always measured in MSL. If you remember that, then you will not have a problem on the exam in regard to AGL and MSL. The only two airspace that is measured in AGL is Class G airspace, and then Class E airspace can be measured in either MSL or AGL. We just went over that in the video previously. And right now we're looking at Class D airspace, which is measured in MSL. You're looking at a 30 with a box around it and a minus sign. What does that mean? Well, if you think that that means 3,000 feet MSL, then you will be making a common mistake. The minus sign means that you can go up to it, but not including 3,000 feet. What that means is that you can go up to that altitude, but you can't go to 3,000 feet. So the altitude with a minus sign that you're looking at for Class D airspace, the box with the 30 around it and the minus sign indicates that the correct ceiling for that Class D airspace is going to be 2,999 feet MSL. Now, if the 30 with the box around it did not have a minus sign in front of it, then you would be looking at 3,000 feet MSL for the ceiling of that Class D airspace. Another common mistake is misreading airport symbols. For example, if you turn to Figure 23, Area 1, you will find Allendale Airport. And notice the little star symbol at the very top. That means that this airport also has a beacon. So let me ask you a question. Does this airport have a control tower? Now, if it took you more than 1 second to answer that question, you're going to make a mistake on the exam because this is something you should know immediately. It's simply because the airport has a magenta color, so therefore it does not have a control tower. Only airports that have the airport symbol colored in blue have control towers, and if you look at an actual photo of Allendale County Airport, you will see that it has a beacon, but it does not have a control tower. Avoid making this common mistake by understanding not only the airport symbols, but understanding what the colors mean. Another way to avoid mistakes is by understanding whether or not you can fly in controlled airspace. Turn to Figure 59, Area 1, and look for Toledo Express, TOL Airport. And quickly, does this airport have a control tower? You see how fast that was? You already knew that answer within 2 seconds. But the common mistake that's made here is, can you fly your drone within controlled airspace? You notice that this is Class C airspace, right? There are two shelves and there are solid magenta lines. I know this is Class C airspace, but the question is, can I fly my drone in this airspace? And if this was a yes or no question, I guarantee some of you would say yes and some of you would say no. But the correct answer is maybe. First of all, anytime you see those rings around an airport for controlled airspace, Class B, Class C, Class D, anytime you see that, you cannot fly in that area unless you have prior authorization from air traffic control. Usually at airports, the way it works is that the inner ring, the surface where the airport and the runways are actually located, they're not going to allow you to fly in that area at all. But as you go further away from the airport and still within controlled airspace, then maybe they will grant you some level of leniency because you'll be able to fly in those areas that are away from the airport despite the fact that you're still within controlled airspace. Now, the further out that you go, the more altitude they'll allow you to fly. For example, if you are so far out that you're almost out of controlled airspace, but not exactly out of the controlled airspace ring, they may allow you to fly up to 400 feet. But the closer you get to the airport, the more and more your altitude will be limited. So the answer, you may be able to fly in controlled airspace, but you will need to get authorization from air traffic control to confirm whether or not you'll be able to fly in controlled airspace. And lastly, and the most common mistake that's made, is that you memorize all of the answers and you walk into the exam knowing all of the answers, and when the FAA asks you the question in a completely different way with completely different answers, you don't know exactly which one to choose. And you must understand the information. You must have knowledge of the information. The answers don't matter, but knowledge of the information and knowing the subject and knowing the topic without even memorizing the questions is what is going to allow you to score high on the exam. The biggest unavoidable mistake is trying to memorize all of the answers instead of trying to learn, study, and retain all of the information on the topics that you need in order to pass the Part 107 exam with a high score. And as a side bonus, I'll give you another mistake. If you schedule the exam before you actually begin studying, you're making a big mistake, because you need to schedule the exam after you have all the information, because you don't know how long it's going to take you to retain all of this information, since we all learn at different rates. So that's all I have for you today. If you have any questions, shoot me a comment, okay? Thank you for watching. I hope this video helped you. See you on the next one.